it is hard to understand the problem, right? So
Yeah.
when you see a problem is hard to understand, check some small examples. Understand it better. Because it says m is at least 5, so we can consider m is 5, okay?
Yeah.
And it says odd integer, so then d of m, these things, so d of 5 is a1, a2, a3, a4, such that which of them is between what and what?
1 and 5.
Exactly. For all of them, such that 5 divides some of them. So now agree that we are understanding the problem better.
Yeah.
Because 5 divides this, there is a polynomial. This one such that dm is qm. Okay. So it says d5 is equal to q of 5. Q of 5 is what? Is c3, 5 cubed plus c2. 5 squared plus c1, 5 plus c0. And then it says for all odd integers m. It says this is correct for 5, this is correct for 7, this is correct for 9, right?
Yeah.
And then it wants us to find C1. So probably from 5 we can reach some good result. From 7, from 9, if you check some of them, then we can find C1, okay?
Yeah.
And because we have 4 variables, probably we can find, if we write 4 equations, we can find. So first, we should calculate D5 is what, right?
Yeah.
Okay, so let's forget about polynomial because it's after that. And try to calculate D5. For finding D5, want hint or want to try on your own?
I can try.
Okay, try.
Here I is from 1 to 4, right?
Yes. I mean, A1, this one,
Yeah.
all of them are from 1 to 5. If you think it is hard, try to solve N1. N1 is easy.
I can solve
Try
it.
to check
I can solve
N1.
it. I was just confused. Okay.
Calculate D of 1. We won't apply D1 for this because it says M at least 5, but for
Okay.
only understand the approach is
Okay.
what. D1 is easier. Try to find D1.
Yeah. Is it just 1?
Exactly, because it is unique and 1 divides some of them, right? Now
Yeah.
calculate M3. D3 is what. Try. So look, A1 to A4 again, because 4 is not related to M. AI is from what to what?
1, 2, 3.
And what divides what?
3 divides the A1 plus A2 plus A3 plus A4.
Exactly. Try to solve this.
Okay. Is it even possible?
Why it's
Do they
not
not have to be
possible?
like distinct?
Look, for example, A1 can be 1, this one can be 2, this one can be 3, this one can be... it says
But they
distinct
have to be distinct.
integers. Wow. So, geometry. So, again, it's 0. So, also previous one is 0. That's the reason it should be at least 5, right? Because they are
Yeah.
different, so it will be easier to check M5, right? They are different.
Yeah.
So, check M5, find D5.
Okay. I get 0.
0?
Yeah.
For example, 1, 2, 3, 4. 1, 2, 3, 4 is good.
Oh, it divides. Oh, never mind. Yeah.
Okay, try.
It's just gonna be the permutation of 1, 2, 3, and 4, right?
Exactly. So it is what?
How do I find it then? Is it
4
is it
factorial.
4 times 4? 16? O4
Why 6?
factorial?
You said permutation of 1 to 4. So permutation. So the first element A1 has 4 cases. A2, 3 cases. 2 cases, 1 cases. 4 factorial.
Oh yeah, 4 factorial. Yeah.
And the reason it is only this case 1, 2, 3, 4, because when you have 1, 2, 3, 4, 5, A1 to A4 is sum of them is what? 1 to 5 is 15. It's
15.
15 minus x, the number that is not here, right? Because it is
Yeah.
multiple of 5, 5 divides this, 5 divides 15, so you can subtract 5 divides x. The only number here is multiple of 5, right?
Yeah.
So because this is 24, you can plug in here 24 and you can find one equation in terms of these things, right?
Yeah.
Okay, now let's try to calculate M7 to see it is what. And then if you can find general form of M, then it will be easier to find C. So try to find this 7 is what, okay?
Okay. I get a permutation of 3, 5, 6, and 7.
Yes, but we should see, we should prove we don't have any other case.
Yes, so like you said there, like so the sum is gonna be 28 minus 3 numbers. I left them
The
like
sum of
B1,
those 3 numbers should
B2,
be
B3,
multiple of 7, right?
7. Yeah, yeah.
So there
So
are
I
a
just
lot of
found that it's gonna
cases
be
to check to reach 3 numbers that are
it's,
multiple of 7.
yeah, but they have to be distinct. So I just get 4, 2, and 1.
Also, you can say
Like these are the
7,
only
1,
two.
and 6, right?
Sorry,
7, 1,
7, 1, and 6.
6. If you remove these 3 numbers, also the left will be multiple of 7.
Oh yeah, that's true.
Okay, so try to see can you find all of the cases. This is a good problem in case work. Then I will tell you how to solve for general M. But for M7, it's a good problem in counting problems and case work. Try to see can you
Yeah,
find all of the
I
cases.
think
Yes.
it's just 7, 6, 1, and 4, 2, 1. Like these two cases, I think.
7, 5,
That's
2.
all I get. Yeah, because I started from 6. That's why I could not.
7, 6, 1, 7, 5, 2, 7, 4, 3. Okay.
Oh yeah, that's also
6,
true.
5, 3. There are a lot of cases. Try to check all of them and try to not ignore any of them, okay?
Okay. I think I get so 7, 5, 2, 7, 6, 1, 7, 3, 4, 6, 5, 3. I think
So
these
how many
should be the
cases you
cases.
found?
Like 4.
Look, let me tell you how you can check to not miss any of them. As I said, you should say, okay, 1 to 7 minus 3 numbers, right? And because 7 divides that, so 7 divides sum of x, y, z, right?
Yeah.
So x plus y plus z can be what numbers?
7, 14, and
Cannot be 21 because we don't have
yeah, 20.
3.
Yeah.
You should select
Yeah.
3, 7. So for 14, again, if we select 7, it will be what if we select 7? What are the cases?
5 and 2, 6 and
Yes,
1,
6, 1,
3 and 4.
5, 2, 3. Okay.
Yeah.
Now suppose that we don't select 7, okay? Then in this case, if we select 6, then it will be what?
5 and 3.
Yes, we need 8 to reach. So only 5 and 3 and what and what? 4 and 4. 4 and 4 are same. So if you don't have 6, 5, 4, 3 is 12 is you cannot reach 14, right?
Yeah. Yeah.
Now suppose the sum is 7, okay? When the sum is 7, we cannot select 7 and 6, right?
Yeah.
So we cannot also select 5 because then 5, 1, 1, right?
Yeah.
So if we don't select 4 also, it won't reach 7, it's 6. So we have to select 4.
Yeah.
So you need
Yeah.
3, 4, 2, 1 only, right?
Yeah.
So now can you tell me this 7 is what then?
We have 5 cases, and um, is it 5 times 4 factorial?
Exactly 5 times 4. Okay. So we can find another equation, but if you want to continue, you can do this. You can calculate 9 and exactly like this 9 and 11 and use casework. And without any idea, you can solve it, but it takes time, right?
Yeah.
Okay. The idea of this is usually these ideas are more useful in full solutions exam, like BMO, British Mathematical Olympiad, or for example, AMO, JMO. Let me tell you the idea as well. Again, the idea of this is famous. Let me tell you a problem that I saw in a book for the first time that I found this idea. It is this. For example, suppose that we have A1, again, like this, A1, A2, A3, A4, A5, and the sum should be multiple of 5, and A1, there are A1 to A5 are distinct numbers, and AI are from 1 to 100. And let me check it again. We had 6 numbers, so A5 to A6. And 5 divides some of them to A6. And, okay, A1 to A6 are distinct. And AI are 1 to 100. And it says what? How many A1 to A6 are there? Okay.
Yeah.
So for this one, want to try a bit on your own or one thing from the beginning?
I can try.
Okay, try a bit.
Yeah, I need a hint.
Okay, sure. So here to agree, we can consider we want to find different cases and then multiply it by 6 factorial, right?
Yeah.
Okay, can you tell me only one case? It is not important that the sum is multiple of 5 or not. Only one case. 6 numbers, any 6 numbers
Um,
from 1 to 100 that are distinct. Tell me an example.
100, 99, 98, 97 to 95.
98, then what?
97, 96, 95.
97, 96, 95. We can check, for example, some more, for example, general, because it is a specific. For example, we can say this one 95, for example. We can write it in increasing order or decreasing order. For example, we can also write, for example, 25, 1, 2, 3, 4, 5, and 2, okay? Okay, then I add 1 to, so it has a sum, right?
Yeah.
And consider sum mod 5, okay, because we want.
Okay.
Now add 1 to each element, and if you reach 100, we consider 1. So it will be 1, 100, 99, 91, 26, and 3, right? So the sum is
Yeah.
what mod 5?
S.
Yes, S, no, it's not S. Pay attention, it's
Is it
what?
S plus 5 now?
S plus 1, because we have 6 elements.
Oh, yeah, that's true.
And also
Yeah.
look, when 100 goes to 1 again, it will be added by 1 mod 5. So S plus 6, which
Yeah.
is S plus 1. So do you agree again if we continue this? 2, 100 plus 1 is 1, 192, 27, 4. Again, it will be S plus 2.
Yeah.
All the way to last set is what? 99. Next one is what?
100?
100, next one.
90, yeah. Then 98?
No, no, no. Not the 100. Look at 100 is here.
Oh, so this is 98, right?
Yes, next one is what?
97?
Yes, next one.
Oh, 92?
No, no, 92 is here.
Uh,
It is first part, it is second part, it is third part, it is 100th part.
is it 89?
Exactly. 89. What's the for next one?
76?
No, it's not 76, right?
Oh, 24.
Exactly. And the next one is what?
Mm. Is it 4?
Yeah, it's 4. No, it's not 4. Look, 4 is here.
Is it 2 then?
It's what?
2?
No, it's not 19.
Yeah, sure.
Oh. But as you can see, directly after one step we reach two. If you consider 100 first step, we agree all of them will be same.
Yeah.
So these numbers are one before that. That's less than 199,
Oh,
99.
that's 1.
Exactly.
That's 1, yeah.
So this one is s plus what?
99?
Is what?
99?
Mhm. Exactly. And can you tell me how many of these summations are multiple of 5?
Multiples? 99 over 5.
100 over
4?
5.
Oh,
Because
yeah.
s plus 0.
Oh,
So
yeah,
this
that's true.
what?
20?
Yes, because in each 5 of them we have one multiple of 5, right?
Yeah.
And do you agree each 6 numbers will be in exactly one of these groups?
Yeah.
Okay, so, and do you agree there are some groups? Like, for example, this one. The first one is S, next one S plus 1 to S plus 99. And all of them are related to each other. And then next one, for example, the sum is S1, S1 plus 1 to S1 plus 99, right?
Yeah.
So, and in each of them, we have 100 numbers, but 20 are good, right?
Yeah.
80 are bad, 20 are good, 80 are bad. So in general, if we answer all of them, and we can split all subsets of 1 to 100 with 6 elements to these circles, right?
I don't get it.
Mm. How many subsets with 6 elements are there from 1 to 100?
100 to 6?
Yes, and do you agree each of them is in exactly one cycle like this? You can write.
Yeah.
Okay. So, how many of these subsets are multiple of 5?
20?
20 in each cycle in total.
20 times 100 to 6?
All subsets are these. How we multiply it by 20? I want to see how many good subsets do we have, okay?
Okay.
Total number of subsets is this. You say the answer is 20. It is greater than total number of subsets. I want to find now good subsets. Okay, number of good subsets. It is what? This one is total number of subsets. So good subsets are what?
Is it 20?
Let me explain this with small numbers on the topic. For example, suppose we have A1, A2, A3, and A4, and we want that 3 divides A1, A2, A3, A4, and our subset is 1, 2, 3, 3 is obvious, 4, 5, what else can we say? 4, 5, 4, 1, 3, 1, 5, after 5. Okay, 6. Okay, now we want to see how many good subsets are there. Okay,
Yeah.
okay, 6 choose 4, 6 choose 2. Okay, so the first one, you can say 1, 2, 3, 4.
Yeah.
Then it goes to what? 2, 3, 4, 5, right?
Yeah.
Then it goes to what? 3, 4, 5,
6.
6. Then it goes to what?
4, 5, 6, 7.
We don't have 7, so
1,
it
I
is 1,
meant.
right?
Yeah.
1, 2, 3, 4. Next one is what? 5, 6, 1, 2, right?
5, 6, 1, 2. Yeah.
Next one is what?
6, 1, 2, 3.
Yes, and this, right?
Yeah.
And in this subset, we have 6 numbers. 2 of them are good, right? Exactly like previous one. Because it is S.
Yeah.
Sum is S plus 1, right? We agree it's S plus 1 because we add 4,
Yeah.
right?
Yeah.
Look, when we from 6 we go 1, it is again plus 1 mod 3, right? For all cases. If we consider
Yeah.
mod 3, S plus 3, S plus 4, S plus 1. So how many subsets here in this cycle are good?
Uh, uh, 2. 6 over 2.
Yes, 6 over 2. And
So,
we can also
yeah,
find them.
3.
We can find them. The first one is 1 mod 3, 2 mod 3, so this one is good, right?
Yeah.
Which one is good? What's the next subset that is good?
S plus 5.
Which one?
S plus 5.
Ah, yes, exactly. This, right?
Yeah.
Okay. Now, 6, 2, 6, 5. Okay. So if you consider next subset, it will be what? For example, 1, 2, 4. Okay, so 1 through. Can you hear me?
Yeah, I can.
Okay, so let's take for example 1, 2, 3, 5, right?
Yeah.
How many subsets do we have? It's 6 choose 4, right? It's 6
Yeah.
choose 2, which is 15, right?
Yeah.
But in each group we have this. Okay, so let's check. 1, 2, 3, 5. We don't have 1, 2, 3, 5 here, right?
Yeah.
Okay, so the next one is what? 2, 3,
2,
4,
3,
6, right?
4, 6.
Next one is
Yeah.
what?
3451.
Next one is what?
4562.
Next one is what?
5613.
Next one, 612.
6122. Yeah.
Oh. And they are disjoint subsets, okay? Because if one of them is same, then the whole cycle is same, right?
Yeah.
Because from one of them, we can determine all other elements of the subset, right?
Yeah.
Here, which of them are good? The first one is 1, 2, 3, 3, 6, 5. This one is good. 1, 2, 3. This one is good, right?
Yeah.
Okay. What is left here? 1, 2, 3, 5. 1, 2, 3, 6. 1, 2, 4, 5. 1, 2, 4, 5. We don't have 1, 2, 4, 5. Do we have? Look, 1, 2, 4, 5. 1, 2, 4, 5.
No.
1, 2, 4, 5. 1, 2, 4, 5. No, we don't have. 1, 2, 4, 5 will be what?
2356.
This one goes to what?
3461.
This one is what?
4512.
It goes here, right?
Yeah.
Okay. Now, do you agree here? How many of them is good? 1, 2, 4, 5 is what? Is 9, 3. This one is good, right?
Yeah.
So now, can you tell me how many good subsets are there?
5.
Yeah, do you agree here? 1/3, 1/3, 1/3. In each cycle, 1/3 of them are good, right?
Yeah.
So do you agree you can say 6 choose 4 over 3? This is 15 over 3, 5.
Yeah.
Okay, and the loop is multiple of 3 because it is s plus 1, s plus 2. If the loop is 3 or 6 or 9, right? So here also
Yeah.
we have some cycle. The length of the loop can be 100 or multiple of 5, right?
Yeah.
And the agree in each of these cycles, we have 1/5 that are good, right?
Yeah.
So can you tell me how many good subsets are there?
Uh, 6 choose 5 over 5
100 choose 6 over 5, right?
total. Yeah.
Exact, total over 5. Okay, understand completely why we divided by this and how it
Yeah.
works?
Yeah.
Okay,
Yeah.
now I want to solve exactly this And this problem, we calculated number of subsets, 100. Choose 6 over 5. But because we should consider the permutation, we should multiply it by what?
6 factorial.
Okay, understand?
Yeah.
Okay. Now we want to calculate D7 with the same way, okay?
Okay.
So for D7, it says again A1, A2, A3, A4. I say, okay, let's add 1 to each of them. A1 plus 1, A2 plus 1. And we consider all of them mod 7, okay? And because it
Okay.
says the numbers are from 1 to 7, after 7 we go to 1 again, and it's good. It's next one after that, right?
Yeah.
A3 plus 1, A4 plus 1. So it is S plus 1. We go all the way to A1 plus 6, A2 plus 6, to A7 plus 6, okay?
Yeah.
If you add 7, they will be same, right?
Yeah.
So how many of them are multiple of 7?
3.
And one thing. If we add how many numbers do we have? 4 numbers. Wow. So, no. It is not S plus 1. It is S plus what? S plus 4, right?
Yeah.
S plus 4, S plus 4 times 2, S plus 4 times 6, right?
Yeah.
I want to prove all these 7 numbers are different mod 7, okay?
Okay.
Try to prove it. We want to find a general way to prove also for any m. Try to prove all these 7 numbers are different mod 7. Try.
How do I even prove it? Because I just see that there's going to be s and then s plus 4, s plus 8, s plus 6, 12, s plus 16, s plus 20, s plus 24. So they're just different from one
Yes,
another.
you can say if s plus 4i is congruent to s plus 4j, you want to see, okay, what can we conclude, right?
Yeah, sure.
Let me ask you this to see you remember. I told you in modular arithmetic, if you have this, if you divide both sides by a, then b is congruent to c mod what?
M over C. GCD of M and C.
M and a, because we divided by 8, right?
Oh, yeah. Divide me. Yeah, yeah.
Okay, so do you agree we can subtract both sides, s from both sides, right?
Yeah.
Then 4i is equal to 4j. Now we can divide both sides by what?
4,
Then I is congruent to j mod what?
7.
Exactly, because GCD of 7 and 4 is 1. And do you agree here it is s plus 4 times 0, it is s plus 4 times
Yeah.
1, so I and j are at this 0 at most 6, right?
Yeah.
So do you agree when they are equal mod 7? They are equal because they have different
Yeah.
remainders mod 7. So all of so
Yeah.
none of this one is different. These these 7 numbers are different. Agreed.
Yeah.
So exactly one of them is multiple of 7, right?
Yeah.
So 1/7 of that is 7. Like here that we said 1/5, and here we said 1/3, right?
Yeah.
So 1/7 of the cases are multiple of 7. So you can say 7 choose. We have 7 numbers. 7 choose 4 over 7, right?
Oh, yeah. Then
And
we get a
we have 7
4
choose 4
factorial.
subsets, right?
Yeah.
And
Yeah.
we know we should divide it by 7 to find number of good subsets, right? Exactly like
Yeah.
previous. Now we want to find quadruple. We should calculate the arrangements, right? Each
Yeah.
subset has how many arrangements, how many permutations?
4 factorial.
Yes. So if we simplify, it is 7. Let's write 7 times 6 times 5 times 4 over 4 factorial. Let's write 4 factorial times 4 over 7, right?
Yeah.
We can cancel 4 factorial, 4 factorial, 7, 7. So it will be 6 times 5 times 4, okay? Now let's check
Okay.
it with our answer here. 5 times 4 factorial, 5 times 4 factorial, it is exactly the same because 4 times 6 is 5 times 4 factorial, right?
Yeah.
Now by the same approach, we want to find dm is what? Exactly, m is odd. M is odd. By the same approach, calculate dm, okay?
Okay. Is it m minus 1 times m minus 2 times m minus 3?
M minus 1 times M minus 2 times what? M minus
M
3?
minus 3.
Okay, let's check. Here, if you want to solve it like this, again, do you agree we can prove that they are different? Like this,
Yeah.
1/mth of the number, because m is odd, right? And when you divide by
Oh, yeah.
4, GCD of m and 4 is 1. That's the reason the problem says m is odd. So m choose 4 exactly like this over m times 4 factorial, right?
Yeah.
So it is m minus 1 times m minus 2 times m minus 3, right?
Yeah.
For 5 also it is same, 4 times 3 times 2, right?
Yeah.
So it is this one. Now we can understand that this one is m minus 1 times m minus 2 times m minus 3. So now calculate, and because it says qx, so you can say x minus 1, right? Because here qm equals dm for all of
Yeah.
them, for all of all these. So For all x odd integers, you can say this. So they should be equal.
Yeah.
Okay, because look, if these two are equal for more than 4 values, then all coefficients are equal. Do you know why?
Wait, why did you write x minus 4?
I'm sorry, explain. Look, these two polynomials are equal for more than 3 values, right? Because it says for all odd integers.
Yeah. Yeah.
If two polynomials with degree 3 are equal for more than 3, if the degree is 3, if they are equal for more than 3 values, then always they are equal and all coefficients are equal. Do you know why?
No.
Because the reason is this. So suppose, for example, it's a famous problem. At first you should know this. Suppose P(x) is a polynomial and the degree is n, okay?
Okay.
How many roots do we have?
N.
Yes, exactly n roots in complex numbers, right?
Yeah.
P of x is n. But if it is 0 for more than n values, suppose, for example, if P of R1 is 0, P of R2 is 0, and they are different for more than P of Rn is 0, P of Rn plus 1 is 0. All of them are 0, and R1, they are different numbers. R1, R2 to Rn plus 1 are distinct. Then what can we conclude if it has n plus 1 roots? Can you guess?
Wait, what's Ri? Like, what's
There are
R1? Are
roots,
they the
roots of
roots?
this, roots
Oh,
of
okay.
this. We know it has n roots, right? At
Yeah.
most, exactly n roots in complex numbers with considering repeated roots. But suppose, for example, for n plus 1 different values, p of them are 0. We have n plus 1 different roots. Then what can we conclude?
P of x equals 0 for all
Exactly.
x.
We can calculate p of x 0 for all x. It means that all
Constant
coefficients are
function.
0.
Yeah.
an equals an minus 1 is equal to a1 is equal to 0, right?
Yeah.
Okay. Now, let me tell you a problem. Suppose x cubed plus, for example, 3x squared minus 5x plus a is equal to, for example, bx cubed plus cx squared plus dx plus 2, okay? And they are equal for more than 2 values. For more than 3 values, 3 different values, okay? It means different values of x, okay? It means that, for example, for x1, if you plug in x1, they are equal. If you plug in x2, they are equal. x3, they are equal. And x4 equal. More than 3 different values means at least 4 different values, okay?
Yeah.
Then can you guess we can conclude what?
B is equal to 1, C is
Yeah.
equal to 3, D is equal to negative 5, and 2 is equal to A.
And how can we conclude this from previous theorem?
Um, we consider the roots. Like, let's say the roots are like R1, R2, R3, and then we just write x
You can,
minus R1
yeah,
and then.
you can take all of them to one side, right? So minus of this.
Yeah.
So the degree of this polynomial is at most 3, right?
Yeah.
But more than the degree, we have roots. So all coefficients are 0. So 1 minus b is 0. So b is 1, right?
Yeah.
Now, here we can use same thing. It says these two are equal. We know d of m. Here. When d of m is equal to q of m, so d of x is also equal to q of x for odd integers x, at least 5, right?
Yeah.
It is only a variable. It's not important. It's x or m, right?
Yeah.
So we can say these two polynomials are equal For infinitely many values, right?
Yeah.
We know if they are equal for at least 4 different values of x, all coefficients, related coefficients, corresponding coefficients are equal, right?
Yeah.
So here we have infinite, so obviously all corresponding coefficients are equal, right?
Yeah.
So we can easily find all Ci. C3 is what?
1.
C2 is what?
-3.
No?
Plus 2 plus 6 plus 3.
Is what?
11.
No, you have careless mistake. The thing you found is C1, not C2, right?
Yeah.
Because look, when you say 1 times 2 times x, 83 times 2 times x, you found coefficient of x. So the answer is 11.
Yeah.
Also, we can find C0 is what?
6. -6.
C1, C2 is what?
-6.
Exactly. Okay, understand completely how we solve this?
Yeah, I did.